So good morning, students. Once again, we welcome all of you for this particular online session on measuring the risk. So today we are taking the measurement of risk. As we have seen the previous session, we have deliberated about the various types of risk, total risk, the combination of systematic risk and unsystematic risk. Systematic risk and unsystematic risk. Systematic risk is a combination of purchasing power risk, interest rate risk, and market risk. Unsystematic risk is a combination of business risk and financial risk. Total risk is measured through standard deviation. Total risk is measured through standard deviation, and systematic risk is measured through beta. So total risk is measured through standard deviation and systematic risk is measured through beta. So today we look at the calculation of standard deviation. So first we'll take total risk. Total risk is measured through standard deviation. So today we will see what is standard deviation, and we will calculate standard deviation of returns using actual return and expected return. The total risk is actual return and expected return. So total risk we need to calculate when actual return is given. That's what we call it, holding period return is given. When the expected return is given, how to calculate the standard deviation. So these two concepts we look at in today's session. Actual return. So what is actual return? The return that the investor is receiving. The investor is receiving from the company. The return is called actual return. So actual return is the holding period return. So that we have calculated in the previous sessions. That is the dividend plus closing price minus opening price divided by opening price into 100. We have calculated the actual return, and we have calculated the average return. We call it arithmetic mean return, and then we have calculated the compounded rate of growth of return by using geometric mean. Now we need to calculate the total risk when the actual return is given. So when the actual return is given, how to calculate the total risk. So the total risk, as we have discussed earlier, can be measured through calculation of standard deviation. Now, what is standard deviation? So arithmetic mean is what? We calculate the average of sales, average of profit. Here, in our case, average of return. That is called the arithmetic mean. Now, how do we get the standard deviation? Any thought? It's a measure of what?
The difference between the mean, the difference you get from the mean.
Yeah. Okay, good. That's good. So the measures of central tendency is the arithmetic mean. So we have arithmetic mean, geometric mean, harmonic mean, median, mode. These are all measures of central tendency. So we need to calculate the central point for any given data. That is called measures of central tendency. The second measure is called measures of dispersion. So how every data points are deviating from the mean. So one of the measures of dispersion is called standard deviation. So we have range, we have mean deviation. So these are all the measures of dispersion. Dispersion means how a data points is moving away from mean. So standard deviation is defined as the square root of deviations from mean. Standard deviation is a square root of deviation from mean. So square root of deviation from mean is called standard deviation. So how do we get that? That is standard deviation squared. So standard deviation is equal to square root of sigma Ri. Ri means the return, the actual return, minus R bar whole square divided by n minus 1. Okay. So sigma Ri minus R bar square divided by n minus 1. So how do we get the entire standard deviation? First get the average. Get the average return. The return is given, get the average return. Average return means total return divided by number of years. So you will get the average return. Then subtract the average return from the return given. Subtract the average return from the return given. That is Ri minus R bar. Then square it. Ri minus R bar, square it. Use the equation. That is square root of Ri minus R bar, square root of Ri minus R bar divided by n minus n. So n minus n, to remove the standard error, instead of dividing it by n, you are dividing it by n minus 1. So we look at the example here. So we are given 5 years. 5 years return is given. First year, second year, third year, fourth year, fifth year. So first year return is 10%. Second year is 20%. Third year is minus 20%. Fourth year is 0%. Fifth year is 20%. Okay. So get the average. Add the return, get the average. So add the return sigma R. Sigma R is equal to 40%. Sigma R is equal to 40%. So R bar is equal to sigma R divided by n. So sigma R is 40 divided by 5, number of years is 5. So R bar is 8%. The first step. The first step is get R bar. That is total the return, aggregate the return, divide by number of years, which will give you the mean return, or we call it arithmetic mean return, or we call it average return. Then second step, subtract average return from the return. That is 10 minus 8. So 10 minus 8, 2%. 10 minus 8, 2%. So you need not write 2%, 2. Then 20 minus 8, 12. Minus 20, minus 8. Minus 20, minus 8. That is minus 28. 0 minus 8, minus 8. Then 20 minus 8, 20 minus 8, 12. Now, this is right. Please check. 30. Is that 40 is right? 40 is right. No, the second one, please take it is 30%. Second one is 30%. Second year is 30%. Minus 20. Now it's right. Okay. So here 30 minus 8 is 22. 22. Okay. So 10 minus 8, 30 minus 8, minus 20 minus 8, 0 minus 8, 20 minus 8. The second step. Then third step, square it. That is 4. 22 square. 22 square is how much? 484. 28 square. 28 square is how much? 784. Please check. 8 square, 16. 12 square, 144. Please check.
8 square.
8 square is 64. Sorry. 8 square is 64. So 144. So please check. Anybody? Please check. Then get the total. Please take your calculator and please check the answer. Okay. So sigma Ri minus R bar square is equal to how much? Get the total. Okay. How much comes?
1.7.
much comes?
148,480.
1480? 1480.
80.
1480. So 1480. So standard deviation square. Standard deviation square, that is variance. Standard deviation square is 1480 divided by n minus 1, that is 5 minus 1. Standard deviation square. Standard deviation square is called variance. Variance or standard deviation square, one and the same. So 1480 divided by 5 minus 1. How much comes? 1480 divided by 4. How much? 3?
70.
370. Then standard deviation is equal to square root of 370. Square root of 370, that is 19.2.
So 19.23.
19.23. That is called standard deviation. I repeat the steps. Step number 1, compute average return. Step 2, compute the deviation from mean. Second step is compute the deviation from mean. That is return minus R bar, deviation from mean. To remove the minus sign, square it. Square the deviations. And to get the variance, the sum of the square of deviations divide by n minus 1, which will give you the variance. If you take the square root of variance, which will give you the standard deviation. Anybody, any clarification with regard to steps? Any clarification with regard to steps? All of you understood? Yeah. Step number 1. You will be given the return. Compute the average return. That is, add the return, divide by number of years. So here the total return is 40, divide by 5 years. So average return is 8%. Second step, compute the deviation from mean. Compute the difference from mean. So how do we get that? Ri minus R bar. Compute the deviation from mean. Third step, square the deviations. To remove the minus sign. Square the deviations. Okay. Then total the deviations. Total the square of deviations. The third step, total it. So divide it by n minus 1, which will give you variance. And if you take the square root of variance, which will give you standard deviation. Clarified? Now how do we get coefficient of variation? Coefficient of variation is the relationship between standard deviation and mean. So coefficient of variation, CV, coefficient of variation is the standard deviation divided by R bar. Standard deviation divided by R bar into 100, which will give you coefficient of variation. So how do we get that? Standard deviation, coefficient of variation is equal to, standard deviation is 19.23. R bar is 8 into 100, which will give you coefficient of variation. That is the relationship between standard deviation and mean. That is 19.23 divided by 8 into 100, which will give you coefficient of variation. So how much we are getting? 19.23 divided by 8 into 100. How much we are getting?
40.
How much? 2 point?
40, sir.
No. 19.23 divided by 8 into 100. It will not come. 214. 214.
40.
Now you are multiply by 100, no?
Yes, sir.
How much comes? 240. 240. Is it right? Check the answer. Please check the answer. 2 point?
240.37.
240.37. Okay. 240.37. Yeah. 240.37%. Hope all of you checked the answer. Okay. Okay. Now, what is the relation with the risk now? So we have calculated standard deviation. Now we have calculated the coefficient of variation. So what is the relationship with the risk now? Okay. Now the standard deviation, the major limitation of standard deviation is that it is an absolute measure. The major limitation of standard deviation is that it is an absolute measure. So what is called absolute measure? It cannot be compared with some other value. Okay. So for example, the particular stock, the standard deviation is 19.2. That's all. If it is compared with some other stock, then we can say. So it is not a relative measure. It is an absolute measure. For example, stock A is 19.2, stock B is 25.72. Then we can say stock A is less risky than stock B. So higher the standard deviation, higher the risk. Higher the standard deviation, higher the variability. So risk means, yesterday we have seen, the previous session we have seen, risk means the variability. So how do we measure that variability? The measurement of variability is done through the calculation of standard deviation. So higher the variability, higher the standard deviation, higher the variability. So if you compare stock A with stock B, then we can come to a conclusion. We can come to an inference that which stock is more risky. The stock which is having more standard deviation, that stock will be more risky. The stock which is having less standard deviation, that particular stock will have a less risk. Okay, so by looking at one particular stock, we cannot come to any kind of inference. The inference can be taken only when as one particular stock standard deviation is compared with another stock standard deviation. Is that clear? The same way for coefficient of variation. So coefficient of variation, higher the coefficient of variation, higher the risk. Lower the coefficient of variation, lower the risk. Is that clear? So standard deviation is an absolute measure. It is not a relative measure. So it has to be compared with some other stock return. So if it is compared with some other stock return, we can come to a conclusion that, but which stock is more risky? The stock which is having more standard deviation, that particular stock will have greater risk. Is that clear? The explanation is clear? I mean, how do you interpret the standard deviation? That's what more important. So here we are not concerned with the calculation. With all this calculation today, we can see you can put it in Excel. Excel will give you a complete the figure. But what is more important is how do we take conclusion? How do we take inference from that particular calculation? That's what more important. So we have a lot of software available today to calculate standard deviation, beta, all that. But the inference, the software will not take. The inference, the software will not give you any kind of inference. And we human beings are required to take inference. That is why, any kind of missions are entirely different from human beings, because we can only interpret from the data. Okay, so interpretation is more important than the calculation. So calculation part, in the real-time situation, lot of softwares are available. With the use of software, you can calculate, but interpretation, we need to make it. Okay, so standard deviation is an absolute figure. We cannot make any kind of inference from the figure what is given. So you need to compare one stock standard deviation with another stock standard deviation. The stock which is having higher standard deviation, which denotes higher risk. Okay. So we'll take one more example. I'll stop there. So look at this. So we are given return.
Yes, sir.
Yeah. First year, how much?
30.
First year 30. Second year
Minus 20.
minus 20. Third year
Minus 12.
Minus 12.
minus 12. Fourth year
38.
38. Fifth year,
42.
42. Sixth year,
36.
36. Now first step, compute sigma r. Compute sigma r. First step, sigma r. Calculate sigma r. How much? Please take your calculator and keep it ready. 19, correct? Sigma r. No. Total of return. Total return how much? Total return. Sum of the returns. How much? Sum of the returns. Total return. How much?
114.
114. 114. So R bar is equal to 1114 divided by 6. That is 19%. R bar is 19%. Then second step. Second step is Ri minus R bar. Subtract R bar from the return. Subtract R bar from the return. That is 30 minus Ri minus R bar. Ri minus R bar. 30 minus 19. 11. Minus 20 minus 19. Minus 39. Minus 12 minus 19. Minus 31. 38 minus 19. 19. 42 minus 19. 23. 36 minus 19. 17. Correct? Now, third step, Ra minus R bar whole square. Square the deviation. Square the deviation. Please tell me the answer. 11 square, 121. 39 square,
1521.
1521. 31 square,
961.
961. 19 square,
361.
361. 23 square,
529.
529. 17 square,
289.
289. Okay? Get the aggregate. Get the aggregate. Sigma Ri minus R bar whole square. Sigma Ri minus R bar whole square. That is how much?
3782.
3782. 3782. So standard deviation square. Standard deviation square. So standard deviation square, that is variance. Standard deviation square is called variance. So standard deviation square is equal to 3782 divided by 6 minus 1. 3782 divided by 6 minus 1. So how much? How much comes?
76.4.
How much?
756.4.
756.4. 756.4. So standard deviation is equal to root of 756.4. Root of 756.4. So that will give you standard deviation. How much? 27.50. Standard deviation is 27.50. Okay. So what do you interpret from this? What is your inference from this? So we can say the standard deviation of returns from this particular stock is 27.5. That's all. You cannot have any kind of inference more than that. The standard deviation of returns of this particular stock is 27.5. If another stock standard deviation is given, we can have a comparison. We can have a comparison and we can say the stock which is having more standard deviation, that particular stock will have greater risk. Is that clear? Anybody got any clarification with regard to calculation and interpretation of standard deviation? Anybody? Any clarification? Anybody? Any clarification? Anyone? With regard to calculation of standard deviation, how to interpret standard deviation?
Sir, the interpretation part, can you please explain again?
Interpretation part,
Yes, sir.
yeah. Here the value is 27.5. Here the value is 27.5. So what do you interpret? The standard deviation of this particular stock return is 27.5. That's all. you cannot have any further interpretation. Why? Because standard deviation is an absolute figure. It is not a relative figure. It is not a relative figure. It is an absolute figure. Absolute figure means you cannot take any kind of inference from this particular value. If another stock standard deviation is given, for example, stock B standard deviation is say 50.2, then you can make an inference. The stock which is having higher standard deviation will have higher variability in return. So that particular stock will have a high risk. So stock B is more risky than stock A because stock B's standard deviation is high. So stock B standard deviation is say 50.2, stock A standard deviation is 27.5. So what is the inference? The inference is that stock B is more risky than stock A.
Yes, sir. Thank you.
Is that clear?
Yes.
Shall we? All of it clear? So this is when the actual return is given. This is when the actual return is given. Okay? Now we are going to calculate standard deviation when the expected return is given. When the economic condition is very strong, the expected return is 40%. So what is the difference between expected return and actual return? Actual return is the investor has invested in a stock market and he has received that particular stock return. He has received it. That is called actual return. Expected return means the investor, before he started investing, he is expecting this much return. So it is his future return. It is not his actual return. The previous one is the historical return, actual return, or we call it holding period return. Expected return is the investor is expecting this much return he is likely to get in the future. Okay? So in the strong economic condition, he is expecting 40% return with 20% probability. So what does it mean? He received 20% probability that he is likely to get 40% return. In average economic condition, normal economic condition, he is expecting 12% with 50% probability. With a 50% probability that he is likely to get 12% return. The weak condition, the recession period, he is likely to get minus 20% return with 30% probability. So in the expected return, we will be given probabilities. We will be given the probabilities. The sum of probabilities must be 1. The sum of probabilities must be 1. So 20%, 50%, 30%. If you add, you will get 1. If you add, we will get 100%. Okay? So we will be given probability and the return. So look at the method, how to calculate when the expected return is given. So slight change in the calculation. That is strong economic condition. Probability is 0.2. Return is RI is 40%. 40. And we have normal economic condition. That is 0.5. The return is 12. And recession 0.3, that is minus 20. The point here is when we are the recession period, you cannot have very high return. You cannot expect very high return. The normal economic period, you cannot expect more than the strong economic condition. So look at that, 40% when there is a strong economic condition, 12% when there is the normal economic condition. So you cannot expect more in normal period. Okay. At the same time, in the recession period, you cannot expect more than the normal period. Okay. So that kind of calculation, that kind of expectation, the investor should have. Okay. Now, how to get R bar? How to get R bar? Okay. That is PI with R. Multiply PI with RI. That is 0.2 into 40. Multiply 0.2 into 40. How much comes? 8.
8.
My 0.5 into 12. 0.5 into 12.
6.
Please calculate. Please calculate. 0.5 into 12.
6.
6. Minus 20 into 0.3. Minus 6. Correct? Minus 6. Correct?
Yes, sir.
Yeah. So now, please look at that. Sigma pi Ri. Sigma pi Ri is 8. Is that clear? Sigma pi Ri is 8. 8%. Unlike historical, this very important point. Unlike actual return, what we do? You add the return, divide by number of years. Here, we need not divide by number of years. Please make it very clear. Here, we need not divide it by number of years. The sum itself, sigma pi Ri itself is called R bar. So, R bar is equal to 8%. All of it clear? Earlier, what we did was, you added the return, divide by number of years to get actual return, to get the average return. But here, you multiply pi with the Ri, sum it, that summation itself is called R bar. Is that clear? All of it clear this point? Multiply, pi will be given, Ri will be given, multiply pi and Ri, sum it, aggregate it, total it, that particular total itself is called R bar. All of it clear? Is that clear? Any clarification? Okay. Now standard deviation. So standard deviation, slight change here, same thing as we done here. Okay. So that is R bar is 8. 8 minus 40 minus 8. That is Ri minus R bar. Ri minus R bar. 40 minus 8, 32. 12 minus 8, 4. Minus 20 minus 8 minus 28. That is Ri minus R bar. Same step. Ri minus R bar. Okay. Then square the deviation as we have done earlier. Ri minus R bar square. Ri minus R bar square. 32 square. 32 square. How much? 1024. 32 square. 1024. 4 square. 16. 28 square. 28 square. How much?
784.
784. Now, please listen. This is what the difference comes. The previous actual return, the sum of square of deviation. The sum of square of deviation itself is called variance. But here, you need to multiply with pi. One more step here. Pi into Ri minus R bar whole square. Multiply with pi. Multiply with pi. That is 1024 into 0.2. 1024 into 0.2. How much comes? 1024 into 0.2. How much comes?
204.8.
20? 204.8. Then 16 into 0.5. 16 into 0.5, 8.
Yes.
784 into 0.3. 784 into 0.3. 235. 235. Okay. Now, please. 235.2. Okay. Now I am writing the equation for standard deviation when the expected return is given. When the expected return is given, standard deviation is equal to root of pi sigma pi Ri minus R bar whole square. That's all. There is no divide by n minus 1. that is sigma pi into Ri minus R bar whole square. Okay, so pi into Ri minus R bar whole square we have calculated. Get the total. Get the total. That is sigma pi Ri minus R bar whole square. How much comes? Sigma pi Ri minus R bar whole square. How much comes? How much comes? Sigma pi. Take the add the total. 204.8. How much comes?
448.
448. 448. 448. Okay. So this standard deviation square is equal to 448. Standard deviation square. That is called variance. So variance is called 448. Take the square root. Standard deviation is equal to root of 448. That will give you the standard deviation. Root of 448 is how much? 21.16, 21.2. I repeat the steps. Step 1, get the average return as we have done for actual return. So here, how do we get the average return? Multiply Pi with Ri. Multiply Pi with Ri. We will be given the probability. We will be given the return. Multiply Pi with Ri. Get the total. The total is called average return. There is no divide it by number of years as we have done for actual return. So get the total of Pi and Ri. So that is called the average return. That is sigma Pi Ri is equal to average return. Then the second step and third step as we have done for the actual return. That is Ri minus R bar. Then third step is Ri minus R bar whole square. Here the extra step what is coming here is multiply Ri minus R bar square with Pi. Multiply Pi with Ri minus R bar square. Okay, so multiply the probability with the deviation square. So get the total. The total itself is called variance. Here we need not divide it by n minus 1. Here we need not divide it by n minus 1. The summation, the aggregation itself is called variance. So square root of variance, square the variance, that will give us the standard deviation. CV we can do it. CV is, that is coefficient of variation is, standard deviation is 21.2 divided by 8. 21.2 divided by 8. Okay.
The previous case we
Multiply by 100. You can multiply by 100. No problem.
So no need to multiply.
If it is, no, since it is given the percentage, since it's given the percentage, you need not multiply by 100. You need not multiply by 100 because 21.2 is a percentage, 8 is a percentage, you need not multiply by 100. The previous case also, you need not multiply by 100 because what is given value itself is a percentage. Okay, so you need not multiply by percentage. It's 21 divided by 8. How much comes? 21.2. Huh? 2.65. The previous case also, you need not multiply by 100 because both the values are percentage. Both the values are percentage in figures. So you need not multiply by 100. So when you divide it 21.2%, 8%, that figure itself is percentage. Okay, so you need not multiply by 100 because both denominators and numerators are percentages. So you need not multiply by percentage. Yeah, I'll solve one more case. Case is there, and additional cases also is there for your practice case. It is given. Please calculate that. It is given here. Please take this. Tell me the values. Take me the values. Pi is 0.2, 0.2, 0.2, then 0.5, then 0.3. The sum of probability must be 1. The return is 30%,
30%.
30%, 18%, 9%. Multiply. Multiply probability with the return. 30 into 0.2, that is 6. 18 into 0.5, 9. 9 into 0.3, 2.7. Add it. Sigma pi Ri. Add it. That is 15 plus 2.7, 17.7. So R bar is equal to 17.7. Is that clear? All of it clear? That is, the summation itself is called average return. You need not divide it by the number of years or the number of conditions here. Because here it's the condition. It is not the number of years. It's a strong condition, normal condition, and recessionary period. What is the probability and what is the return? So you need not divide it by the number of conditions. The summation itself is called the return. Okay. Now, second step, Ri minus R bar, that is 6 minus 17.7. 6 minus 17.7 is 11.7, correct? Oh, sorry. 6 minus 17.7, that is minus, how much comes? 6 minus, how much?
7.7.
Yeah, 6 minus 17.7. Get the values.
Minus 11.
Minus 11.7. Minus 8.7. 2.7. Minus 15, correct? Please check. Please check.
Ri minus
Ri minus R bar.
minus 17.7.
Ri minus R bar. Yes.
30 minus.
Oh, sorry. Oh, sorry. I thought. Yeah. Correct. Yeah, 30 minus 17.7. Yeah, sorry. So 30 minus 17.7. How much comes? 12.3. Sorry. 12.3. 18 minus 17.7. 1.7. 9 minus 17.7. Minus 8.7. Correct?
No, second one.
Minus.
0.3.
Huh?
Second one. 18 minus 17.7.
0.3. Okay. 0.3. Correct. 0.3. Then 9 minus 17.7. How much comes?
Minus 8.7.
Minus 8.7. Square it. 12.3 square. 12.3 square. 144. How much comes? 0.09.
151.29.
1. 151.29. Then 0.3 square, 0.09, correct? 0.09, no?
Yes.
0.09. 8.7 square. 8.7 square.
75.69.
75.69. Now, multiply with, this is the extra step that we have. Extra step that we have is 151.29 into 0.2. 151.29 into 0.2. 0.09 into 0.5. 75.69 into 0.3. Multiply with probability. That is 151.29 into 0.2. How much comes?
30.2.
30 point? 30.25. 30.25. Then 0.09 into 0.5. 0.045, correct? 45. 75.69 into 0.3. 75 points.
22.70.
80.
22.70.
22.70. Yeah. Then get the summation. That is sigma pi into Ri minus R bar whole square. Sigma pi into Ri minus R bar whole square. How much it comes? Add the total. Add the total.
7.28.
How much comes? Total how much comes? 52.995. So please check. Please check.
So we can figure it until 53.
50? 52.995. Yeah.
So we can figure it
53.
53.
Yes, yes. You can make it 53. Correct. So standard deviation square is called 53. Standard deviation square is 53. Huh?
7.28.
Yeah. So take the square root. Standard deviation is equal to square root of 53. 7.28. 7.28%. So coefficient of variation is 7.28 divided by 17.7. Both are in percentages. You need not multiply by 100. So 7.7, 7.28 divided by 17.7. How much comes?
0.41.
0.4. 0.4. 0.41 percentage. Okay. So when you compare the previous return, you can compare now. The previous calculation, what was the standard deviation? Previous calculation, what was standard deviation? Previous calculation, what was standard deviation?
27.5.
The previous calculation, stock A, the standard deviation was how much? Previous,
27.5.
how much?
You mean the previous sum?
Yeah, previous sum.
27.5.
27.5. So 27.5. 27.5. And stock B is, now we have calculated 7.28. Okay. Now coefficient of variation, stock A, the previous one, how much was stock coefficient of variation? Previous one?
1.44.
Previous one. We have calculated now.
Yeah, 1.44. Yeah.
1.44. Here 0.41. So what's interpretation? What's interpretation? Stock B is less risky. Stock B is less risky because stock B's standard deviation is low. So when we compare with the stock A, stock B's standard deviation return is low. So that particular stock is having less risk. Is that clear? When the standard deviation is low, the coefficient of variation will also be low. So higher the coefficient of variation, higher the risk. So any calculation, any doubts, any clarification. So we have done actual return, how to calculate standard deviation and the coefficient of variation. And when the expected return is given, how to calculate the risk and standard deviation.